Good morning, everyone. Am I audible? Just can anybody just acknowledge?
Yes, sir.
Yes, sir.
Okay, thank you. Okay, so in yesterday's session, we have discussed this one example. In today's session, we are planning to have the completion of the three examples. Today, we are only going to discuss the mathematical modeling, no more theories in today's session. So, we have discussed that okay, company was manufacturing two types of the chocolate, that is type A and type B, and each chocolate or each unit of A requires um, 1 unit of milk and 3 units of choco. So what we have done, if you can see over here in the tabular format, we are having milk and the choco as the ingredients, and the company is manufacturing A and B types of the chocolate. So we have simply noted down the data over here that okay, 1 unit of milk. So over here one is there, and 3 units of the choco for type A. We are having this 3 units of the choco and 1 unit of milk. Same for unit of B, we are having 1 unit of the milk and 2 units of the choco. It is given that the company has a total of 5 units of the milk and 12 units of choco. So this is what the company is having. That is the availability is 5 and 12. So ultimately, whatever units we are using should be less or equal to the availability. That is nothing but our total production should be less or equal to the 5. This is what the company is having. And same case for the choco, that is the total unit of the production or the total unit of the usage should be less or equal to the available number of the units. So that means we have done this particular thing as a constraint. We have taken this particular thing as a constraint. On sale, company makes the profit of rupees 6 and rupees 5 on type A and type B respectively. So we have simply written 6 and 5 over here, which is the profit. And since we know that our profit is the term that we actually try to maximize, so that is our objective function. We have considered that okay, let x1 number of the units of A are produced. So we have just take consider this one, that let x1 units of A are produced, let x2 units of B are produced, and so thereby our profit will be nothing but to maximize this 6 into x1 plus 5 into x2. So this is our objective function. The constraints are nothing but our milk and the choco plays the role of the constraints. So the unit of the milk that is available is 5. So ultimately it will be less or equal to 5. For the milk I am writing 1 unit of A, 1 unit of B. So that means x1 plus x2 should be less or equal to 5. Same case for the choco. If I write over here the choco, then for the choco, we are having available units are 12, 3 for A and 2 for B. So it will be 3 into x1 and 2 into x2, where x1 is for A and x2 is for B. Along with this, there are our functional constraints. Along with this, our x1 and x2 should be greater or equal to 0. Why? Because they are the number of units and the units cannot be negative. So they are the non-negative constraints. They are the non-negative constraints. So this is what our mathematical model will look like. This is what our mathematical model will look like. So this is what we have seen in previous class, in yesterday's class. So if anybody is having any doubt, then you can ask me. Anybody having any doubt? Okay, fine. So I am receiving the messages that it's clear. Okay, so let me just focus on to the next question. So this will be our practice of all the mathematical modelings. So let me just drag the slide over here. Okay. So now everybody just read this question and try to formulate the mathematical model. You will be having 5 minutes to formulate the mathematical model, and then we will be having for the discussion for the next 7 to 10 minutes. This is how we would be able to complete 3 questions. This is what is expectation. Now let's see what is the reality. Anybody can volunteer for explanation of this particular example. The more often you volunteer, it will be better for you to also grasp this concept of mathematical modeling. This is for the first time, I guess, you are exposed to development of the mathematical models. Okay, anybody can volunteer in explanation?
Hello, sir.
Yes.
Sir, I'd like to explain.
Yes, please explain.
Sir, in this question, it is given that the farmer has 110 hectares piece of land, and he decides to grow wheat and barley on the land, but it is not sure on how many hectares does he will grow wheat and barley. We have to find the optimal solution for that, and it is also given that the whole of the production will be sold because it has excellent climate for the cultivation of this crops. And also it is been told that he's been asking us that how much profit can be, how much maximum profit and labor requirements uh, will be given to us if the farmer has a budget of US dollar 10,000, and he has availability of 1200 man days. He has 1200 days in his hands, and he has dollar 10,000 budget, and he's asking us to find the optimal solution of how much the each crop has to be grown, and the specifics have been given that the cost price of wheat is 100 and that of barley is 200, and the net profit is 50 and that of barley is 120, and likewise the main days are also been given per hectare. So he's asking us to find the optimal solution and optimal value.
Okay, fine. Correct. So whatever explanation has been given, it's completely correct. So the farmer has recently acquired 110 hectares piece of land, and he decides to grow wheat and barley on that particular land. So in a particular land, let's say this is what he is having. Let's say it's 110 hectare, and in that he decides to have the growth of the, let's say, wheat and barley. Don't say that I want to grow wheat more and so on. It's just the example. So let's say he's dividing the land into two parts where he would be growing wheat and barley, but he don't know how much part he should be having for wheat and how much part he should be having for the barley. So what is asked us that you need to find out how many parts I should be having or how many hectares I should be having. So let's say let x1 be number of hectares, number of hectares for wheat, and let x2 be number of hectares for barley. So this is what we assume that okay, the farmer can grow x1 hectares for wheat and x2 hectares for barley. So this is what is our decision variable. This is what our decision variable is. Now, the optimal solution we need to find out. So whenever it comes to optimal solution, the optimal solution will be having certain objective function. It will be having certain objective function. So over here, what will be our objective function? What will be our main parameter? Can anybody just tell me? What would be our main parameter?
Net profit per hectare.
Right. It will be the net profit. So this is the net profit per hectare. It's given per hectare. We have assumed that, okay, we would be having X1 units of wheat and X2 units of barley. So, okay, before revealing the entire answer, or before discussing the entire answer, I will be giving you 2 to 3 minutes to have your own thinking and develop the mathematical model, and then I will be explaining you. So let me just pose myself over here and just try to develop the mathematical model by your own self for 2 to 3 minutes, and then I will be explaining you. I have given you the rough idea what is supposed to be done. You can just write your answer in the chat box. Okay, let me again remind you one thing that we wouldn't calculate as of now the profit values. We won't be calculating the profit values. Only intention for us is to develop the mathematical model. From the after two sessions, we would be exploring the methods corresponding to calculating the optimal value, where we will be finding the answers for all these questions. So don't worry about that. We will be definitely finding the answers. But as of now, our main intention is to learn, develop the mathematical model. So don't calculate the values, but just at least develop the mathematical model, and that will be the only intention. I don't want the values. Okay, I received answer from Isha, Soham, Prerna, Akshat, Karan, Het, Hiral. Okay, so many of you have only sent me the objective function, so you can also try it out for the constraints. Okay, so let me just start discussing the answer. We have been given that okay, we need to find out how many hectares of wheat and how many hectares of barley should be produced. So what our first task will be to decide the decision variables. So we have decided that okay, x1 and x2 will be our decision variables, which will be serving as the hectares of wheat and barley respectively. So I've simply written over here x1 and x2. Our profit is rupees 50 per hectare and our profit is rupees 120 per hectare. Now that means we would be having the maximization of the profit, and it will be nothing but it will be maximization of the profit with respect to the equation will be 50x1 plus 120x2. That means this is the profit per hectare. I am growing x1 hectares, then the profit will be 50x1. This is the profit per hectare. I am growing x2 hectares, so my profit will be 120x2. So that means I have considered this net profit column. We have been given the constraints. We have been given the constraints. The constraints are, let me just take more space to write the constraints. Okay, Shyam is you are also given the answer, fine. Okay, so the constraints are, let's say the first one. The constraint, let's take this cost value. The farmer has a budget of US dollar 10,000. This is the budget that he is having. So what does this cost value means that for each hectare in growing wheat, for each hectare, the farmer is costing 100 rupees. And for each hectare of barley, he is costing 200 rupees. He is costing 200 rupees. But what he has the total of 10,000 US dollars only. So what we need to do, our overall production, let's say we have grown x1 hectares of wheat where each hectare is costing us 100 rupees. Plus, we have grown x2 hectares of barley where each hectare is costing us 200 rupees. This should be less or equal to 10,000. This should be less or equal to 10,000. This is the constraint corresponding to cost. Now the second constraint is the man days. The man days, the labors. How many days the labors will require? So for the wheat, it requires 10 man days for each hectare. And for barley, it requires 30 man days for each hectare. So ultimately, if you just look out for it, they are having 1200 man days. So whatever value we will be having will be less or equal to 1200. Thereby, if I just say that, okay, per hectare, I am requiring 10 man days. So for x1 hectare, I will be requiring 10 x1 man days. So I will be having 10 x1 plus per hectare, I am having 30 man days for barley. I am having 30 man days and I am having overall x2 hectares. So this is the constraint for man days. We have covered this table. Are there any another digits that are left to be covered? You need to make this thing sure that whatever digits that have been given to you is conveying some or the other meaning. We are having this particular, all the digits in the table are been covered. I have seen answers for 2 to 3 people and I have seen that they have covered all the digits that have been mentioned in this particular table, but they haven't covered this particular value 110. So what we need to consider over here, we simply need to take into account the third constraint. Now this particular thing is the entire land that the farmer is having. The farmer is having 110 hectares. He is producing x1 hectares of wheat and x2 hectares of barley. So it will be nothing but x1 plus x2 less or equal to 110. X1 plus x2 less or equal to 110. This is the land, the constraint of the land. These are all the functional constraints. These are all the functional constraints. If I consider the non-negative constraint, then it will be nothing but x1 and x2 must be greater or equal to 0 because they are the piece of the land, they are the hectares, they are the area, and the area cannot be negative. So that is the reason we are considering this to be the greater or equal to 0. I'm not over here. If you just focus the point, what I'm trying to say, I'm always writing non-negative constraints. I'm not writing positive constraints. There is a much difference in the non-negative constraint and the positive constraint. Non-negative constraint includes 0 also, while positive constraint doesn't include 0. It is strictly greater than 0. I'm not saying this thing. I'm saying this one, non-negative constraint. X1 x2 greater or equal to 0. This is the non-negative constraint. Anybody having any doubt in this particular question? Is this particular question clear? Okay, fine. So I hope till this point of time, we all are aligned in learning these things. So let me give the third question. And this question, I want everybody to solve. I won't be asking anyone, but I will be just randomly picking up the person to solve it. Okay, so let me just give the question. Okay, so this is the question that you can read. It's 11:40, so I would be giving the time till 11:46 or 47. am having 5 people who have given answers. So Akshat, Het, Karan, Isha, and yes, okay, Karan has given the answer. Prerna has given the answer. So I'm waiting for 2 more minutes. Okay, Nisit has given answer. Viraj also. Okay, fine. So let's start discussion about this particular question. So anybody, if you can volunteer to explain this question, what it tries to say. Anybody?
Yes, sir.
Yes.
Yes, sir. So we are given that a company manufacturing two types of chips, chip A and chip B. For each chip, we are giving the unit selling price, which is proportional to its selling price, profits, and then we are given the hours of skilled labor to produce chip A and B, hours of unskilled labors to produce chip A and B, and raw material. And we are given some constraints like total 100 hours of skilled labors and 70 hours of unskilled labors are there, and total 30 units of raw material are there for company. So we need to find that we need to make chip A and B in such proportion that uh, we we get maximum profit out of it.
Okay, fine, correct. So whatever explanation there has been given, it's completely correct. So it says that a company manufactures two types of the chips, that is A and B. So let me write over here A and B. So whatever manufacturing are there, let's write over here. And whatever, these are the products. If I just write it, these are the products. In each of the examples, we have seen this only. Over the columns, we would be writing the ingredients. Ingredients or the resources. In this particular case, we would be having the resources and not the ingredients, because they are not the thing that we are used to eat up, the skilled labors, and we don't eat up, so they are the resources. So it says that okay, the unit selling price for A and B is rupees 15 and 25. The profits are proportional to the selling price. So that means we can say the selling price. In this particular case, we have been given the selling price, and for A it's 15, for B it's 25. The profits are proportional to the selling price. That means if you increase the selling price, our profit will also increase. If we decrease the selling price, our profit also decrease. They are the proportional things. To manufacture A, the company has to invest 3 hours of skilled labor. So this is nothing but our resource. I'm writing SL, that is nothing but the skilled labors. In short, I'm writing SL. So the company has to invest 3 hours of skilled labors. So I want to invest 3 hours of skilled labors for A, 2 hours of unskilled labors. So I'm writing over here unskilled labors is UL. So it's 2, and 1 unit of raw material. So I am writing RM, that is raw material, it's 1. Similarly, we have been given the data for B, that for B it's 4, 3 and 2 hours. So it's 4, 3 and 2 hours respectively. The company has 100 hours of skilled labor. So now it comes the availability. It comes the availability. So in this case, We have been given the availability over here. Over here, we have been given the availability. So let me just erase the availability in this particular case. Okay. So in this case, we have been given the availability as the company has 100 hours of skilled labor, so it's 100. 70 hours of unskilled labor, so it's 70 over here, and 30 units of raw material, so it's 30. Now, we have been also given that the company has to produce at least 3 units. So this is much required word, at least that is the minimum. So let me write the over here, it has to produce. So requirement, I will be writing over here the requirement. Requirement is greater or equal to 3 units for A and 5 units of chip B. So it will be greater or equal to 5. Now this is the new addition to our table, the column of requirement. So if you can just realize, we are going step by step. We are increasing the difficulty. So the requirement for A is at least 3 units, for B it's 5 units. So let's make the mathematical model. The objective function is nothing but, our objective function is to maximize this selling price. So I will be writing over here, maximize selling price. You can even write maximize profit because it has been given profits are proportional to selling price. So let me say that, okay, I'm not going to write the entire sentence now that, okay, the company manufactures X1 units of A and X2 units of B. Let me say this thing, that the company manufactures X1 units of A and X2 units of B. So our objective function will be 15x1 plus 25x2. Maximize this thing, 15x1 plus 25x2. Now comes our constraints. Constraints. The first constraint is for the skilled labors. I'm writing for the skilled labors. It is the availability. So that means all these things needs to be less or equal to this available entity. So 3x1 plus 4x2 must be less or equal to 100. The second case is the unskilled labors. It's 2x1 plus 3x2 must be less or equal to 70. The third case is of raw material. It's x1 plus 2x2 less or equal to 30. So we have covered all the values except these requirements. So these requirements are also the constraints. The requirements are also the constraints that you at least require to produce this thing. That is the, whenever the term at least comes, it's the constraint. So your fourth constraint will be the requirement. That means x1 greater or equal to 3 and x2 must be greater or equal to 5. This is the requirement. So it means that you need to produce this much thing. You need to write this much thing. Now, if I say about the non-negative constraint, now let me just write over here the non-negative constraint. It's x1 greater or equal to 0, x2 greater or equal to 0. This we usually write, which we were writing till this point of time. But if you can just correlate these two things, x1 greater or equal to 3, x2 greater or equal to 5, and this one. So that means my x1 must be greater than 0, and in the requirement it's given that x1 greater than 3. So that means this both constraints by default they serves as the non-negative constraints also. So we don't need to write this non-negative constraint in this particular example, because if you just observe this particular constraint, the fourth one, the requirement constraint, it itself serves as the non-negative constraint. So we don't need to require the non-negative constraint because it itself serves as it. Anybody having any doubt in this particular question? Is it clear? Are you all enjoying this type of questions? Right. So Viraj has a question that if we see the resources which are greater than zero, so no need to write the non-negative constraints. Okay, fine. Correct. So you don't need to write the non-negative constraints if you already say that, okay, this x1 must be greater or equal to 3, x2 must be greater or equal to 5. So it itself includes the non-negative constraints. So if that is the intention that has been carried out forward, then you don't need to write non-negative constraints. But to clarify this thing, if it is been given that, okay, the sum of, let me write over here, sum of production of chip A and B needs to be at least 5. If it is given like this, then it means that x1 plus x2 must be greater or equal to 5. Now this don't serve as the non-negative constraint. This don't serve as the non-negative constraint. So at this particular time, you need to write x1, x2 greater or equal to 0, because it doesn't mean that both the values are non-negative. If it means that both the values are non-negative, then and then only you need not write this non-negative constraints. Else you need to write the non-negative constraints. So in short, in any of the mathematical model, you would be having the objective function, functional constraints, and the non-negative constraints. So over here, if you can just look into this particular formulation, this is the objective function. 1, 2, and 3, this all the things solves the purpose of the functional constraint, and this itself shows the purpose of the non-negative constraint, because we don't have any another variable that is associated with them. Okay. So let's practice another question. I hope you all will be now able to solve these questions, and at least it is quite much simple and easier than what we have learned in our previous semester, the typical difficult algorithms. So it's quite easier than that one. So let's try to solve the next example. So try to solve it quickly within 5 minutes, and then we can discuss it for the next 5 to 8 minutes. Okay, last 1 minute, and then you can just write the answers. I have received the answers from, let me just focus on the answers from Prerna, Dipesh, Akshat, Isha, Nishit, Karan. Okay, from few of you, I have received only the partial answers. Okay, fine. So let me just directly write the tabular format because we are having only 7 minutes. So I've just gone through many of your answers and they are almost correct. Not everybody's answer are fully correct, but they are almost correct. So with the practice, you can definitely have a good grasp on this particular thing. Okay. It is given that a pharmaceutical company produces three types of medicines, M1, M2, and M3. So that means the products would be nothing but M1, M2, and M3. They are the products. And for manufacturing these medicines, threefold types of the ingredients L1, L2, L3 are required. So let me write over here L1, L2, L3. They are required. Okay. The next thing is given that 1 M1, that is nothing but it means 1 unit of M1 requires 3 units of L21. So I will be writing over here 3. So let me just change the color. It looks good. So let me just write over here 3. And 2 units of L2. 2. 1 M2 requires 2 units of L1. So 1 M2 requires 2 units of L1 and 3 units of L2 and 4 units of L3. 1 M3 requires 4 units of L1. Um, okay, I'm over here. Requires 4 units of L1 and 3 units of L3. So if I can see over here, the remaining blocks are empty. The remaining blocks are empty. So I'll be putting over here 0 because it doesn't require, suppose M1 doesn't require the ingredient L3. M3 doesn't require the ingredient L2. So I will be putting over here 0. By default, there would be 0. The company has a stock of 40 units of L1 and something for L2, something for L3. So let me write over here availability. So it will be nothing but the company has a stock of 40 units of L1, 40 units of L1, 30 units of L2, and 45 units of L3. The profit per unit for M1, M2, M3 are so and so. So let me write over here the profit. Profit for M1 is 8, for M2 is 13, for M3 it's 10. Formulate the problem so that the company maximizes the profit. Okay, so if I want to say, let's say that the company manufactures X1 units of M1, X2 units of M2, X3 units of M3. So this is the by default thing that you need to write, that let X1, X2, X3 are so and so for, let's say, M1, M2, M3 units of the production. They are all our decision variables. You can take any value. I have seen many of you have taken M1, M2, M3. Many of you have taken Y1, Y2, Y3, I1, I2, I3, but it's completely fine. You just need to mention over here, let so and so be the number of units of M1, M2, M3. Okay. If I write objective function, it's nothing but to maximize the profit. The profit is nothing but this column. So it will be 8x1 plus 13x2 plus 10x3. Constraints are, if I just write the constraints, constraint for, let's say, L1, if I'm writing for L1, for L1, if I'm writing, it will be 3x1 plus 2x2 plus 4x3. Here is the maximum price, the units that are available, so it should be less or equal to 40. 2x1 plus 3x2 must be less or equal to 30 because I need not to write over here 0, 40 because 0 into x3 doesn't mean anything. So this is for L2. For L3, you need to write this one 0x1 doesn't mean anything. So 4x2 plus 3x3 less or equal to 45. And the non-negative constraints, they are x1, x2 must be greater or equal to 0. That's it. This is the mathematical model. This is the mathematical model.
Sir, x3 also in non-negative.
Yes, I just forgot. X3 also non-negative. I just went into the flow of the previous examples. So x3 must be greater or equal to 0. Okay, so I guess you are now quite familiar with how to develop the mathematical models. So let me declare one thing that in the next week, if I don't know if we have any lecture tomorrow or not, I'm not very sure whether we would be having the lecture tomorrow or not. So I would be again taking the examples for the mathematical modeling in the next lecture. I will be taking 2 to 3 other examples also corresponding to this mathematical modeling. And in the next lecture after that, so I guess from this lecture, the second lecture, in the next lecture we'll be having the discussion of the mathematical modeling again, and in the next lecture to that we would be having the exam. So I'm declaring now only that we would be having the exam after one lecture. The exam will be pertaining to the mathematical modeling. The exam will not be 1 hour, it will be only 15 to 20 minutes because it doesn't require much time. So we would be having the exam of around 10 to 15 marks. I don't know how many questions I may ask, but of around 10 to 15 marks. So you can start preparing from JK Sharma book. And plus, let me give one question as a part of your practice in homework. So I will be just pasting the question over here. So I will be giving you 2 questions that you need to do. So if you can just take the screenshot, just wait a minute once again. Okay, so these are the 2 questions that you need to do as a part of your homework. So I would be requesting anyone if you can just take the screenshot and put it in your group. This is the question 5. This is question 6 or the example number 5, example number 6. We have done the 4 till 1, 2, 3, 4. We have done till 4. So anybody just take the screenshot and keep it in your group or in your WhatsApp group so that everybody can take a note of it. And quickly you can just write your roll number and name in the chat box. And you can join your next session. So thank you everyone. You can just write your roll number name for attendance.